Alright, here we go, 2010 number 3. Um, Hopefully you've already gone through this and are familiar with the problem. Uh, we've got 700 people initially in line. Oops, let me get my marker back. Um, and For this ride, and oops. Okay, so we got 700 people in line, 800 people per hour ride the ride, and R of t is the function at which people arrive at the ride throughout the day, or that's how many people get in line throughout the day. T is measured in hours from the time the ride begins operation. How many people arrive at the ride between 0 and 3? So A. So from 0 to 3, here's 3 o'clock. And if this is in people per hour, and this is in hours, then this area here represents the total number of people that are in line, right? This is people per hour in line. Okay, so A would represent, let me write it like this, save some space up here. I'm going to split this into 2. You do have your calculator to do this, or to help you with this. This is 2 trapezoids, so make sure you know the formula for trapezoids. 1/2 base 1, 1,000, plus 1,200 times the height, which is the distance in between here, 2, plus 1/2 base 1, 1,200. That's 1,200. Plus 800 times the height. And if you do that, you get 3,200. Oops. 3,200 people. So 3,200 people got in line from 0 to 3 hours. Okay, does that make sense? B. Is the number of people waiting in line to get on this ride increasing or decreasing between 2 and 3? Justify your answer. So from 2 to 3, is the line getting longer or shorter? Is really what it's asking, right? Are the number of people waiting in line increasing or decreasing? Well, how well you can answer this question or how fast you get it is recognizing this point right here. At 3, there's 800 people per hour waiting in line. And recognizing this fact right here, 800 people per hour get onto the ride. So at 3 o'clock, at 3 hours, you have exactly the same number of people getting onto the ride as are getting into the line. So at that exact moment, the line stays the same length. Before that point, you have more people getting in line than getting on the ride. After that point, you have more people getting on the ride than you do getting in line. So the line's getting shorter afterwards. The line's getting longer before. And that's really the only thing you need to say. So from 2 to 3, R of t is greater than 800. So the line is increasing. Okay, and I'll write this for you guys. Since 800 people per hour are getting on the ride. Okay, C. At what time is the line for the ride the longest? Well, we kind of already just mentioned it. Same exact reason. At 3 hours, before 3 hours, the line's getting longer and longer and longer. At 3, the line is staying the same because at that moment in time, the same number of people that are getting into line are getting onto the ride. And afterwards, you've got more people getting on the ride than are getting in line. So you just have to make that same argument that you did in B, except finish it off. For t less than 3, r of t is greater than 800. For t greater than 3, r of t is less than 800. So t equals 3, r of t is maximum. R of t is largest, and so the line will be the longest. I guess that's not technically right, because it's not that r of t is the largest, because r of t is the largest at 2. It's so t is equals 3. Let's do this instead. The line will be the largest because r is the rate at which people go into the line. So since it's greater than 800 before 3, and after 3 it's less than 800, and 800 people are getting onto the ride, the line will be the longest at that moment. So that would be sufficient right there. And then how do we figure out how many people are in line at that time? Well, at 3, how many people are we going to have on the ride? Well, let's figure this out. How many people did we start off in line? We start off with 700 people. Oops, it's kind of messy. We started off with 700 people waited in line at 0 hours, plus 3,200 people were added to the line from part A between 0 and 3. And then I had to take away how many people per hour did we lose from the line. Well, 800 people per hour times 3 hours. So if we do that and do the math, we got 39 minus 24 is what, 1,500 people will be in line. All right, and then D, last one, write but do not solve an equation involving an integral expression for r whose solution gives the earliest time t at which there is no longer a line for the ride. So I don't want a line for the ride. So what has to happen? Well, let's see. This right here, 0 to t. Now I'm gonna say r of t dt. But again, I mentioned before, that's bad to use this t and this t the same thing. So I'm going to change this t, and it doesn't matter. I could use x's or I'll use the s. So we don't use x's since we reserve that for just kind of general equations. This right here represents the what? People per hour in line times the number of hours. So this is the people in line, right? So we got the people in line that have accumulated from 0 to t plus the 700 initially, and I want those people to equal. Remember, I'm trying to write an equation when there's no for t when there's nobody in line. So this right here needs to equal the total number of people that have ridden the ride. Well, how many people have ridden the ride after t, if t represents the hours since it opened? Well, 800t, because 800 people times the number of hours, this is the number of people on the ride. This is the people in the line. And when these two numbers are equal, that means there's no line, right? So here's my equation that I would solve to figure out when there's no more line. Okay? All right, there you go.